So we'll do a few problems before going ahead with the concept. The system matrix of LTI continuous time system is given by A is equal to 0, 1, minus 4 and minus 5. What are the roots of characteristic equation? So what is a characteristic equation? We have seen that determinant of Si minus A is equal to 0. If you equate this to 0, you will get the characteristic equation, right? Roots will be the roots of this characteristic equation. So now we have the matrix A, right? So what will be S times I? I will have the same order as matrix A. This is 2 into 2, so I will also be 2 into 2. So determinant of S into I will be 1, 0, 0, 1 minus A will be 0, 1 minus 4 minus 5. Okay. So first you have to subtract this and then you have to find the determinant of the resulting matrix. So what will be the resulting matrix you are going to get? S minus 1, 4, S plus 5. This is equal to 0. So you are going to get S into S plus 5 plus 4 is equal to 0. So the characteristic equation is S square plus 5S plus 4 is equal to 0. If you find out the roots, you are going to get S is equal to minus 1 and minus 4. So these are the roots of the characteristic equation. Next question we have, given the matrix A is equal to 0, 1, 0, 0, 0, 1, minus 6, minus 11, minus 6. The eigenvalues of A are. So how do you solve this? In order to get the eigenvalues, you have to first equate this determinant of this matrix to 0. Lambda I minus A is equal to 0. So what will this be? Lambda minus 1, 0, 0, lambda minus 1, 6, 11 and lambda plus 6. This is equal to 0. So here you are going to get lambda into lambda square plus 6 lambda plus 11 plus 1, 0 plus 6. This is equal to 0. So what will be the equation that you are going to get here? Lambda cube plus 6 lambda square plus 11 lambda plus 6 is equal to 0. Now since this is a third order equation, how do you get the roots? First you have to try different random roots, trial and error method, okay? Once you get one root, then you can get the other two roots easily, okay? So let us first try 0. If you put lambda is equal to 0, then you are going to get this function will become 6. So 6 is not equal to 0. Now you put lambda is equal to 1. Here what you are going to get, this will not anyways be correct because all of the terms here are positive. So if you put a positive term, it will not become 0, right? So let us take a negative number. Let us take minus 1. Lambda is equal to minus 1. Then what you are going to get? Minus 1 plus 6 minus 11 plus 6. This you are getting as 0. So lambda is equal to minus 1 is 1 root. Whenever there is a cubic equation that is given, usually it will be easy to get the first root. Don't have to worry. Okay. Now once one root we got, how do you find the other two roots? Okay. So now we can say that lambda plus 1 into some function is equal to lambda cube plus 6 lambda square plus lambda 11 plus 6, right? This equation you can write in terms of its roots as how much? If lambda 1, lambda 2 and lambda 3 are roots, then you will write lambda minus lambda 1, lambda minus lambda 2 into lambda minus lambda 3. Now we got one root. What was it? Minus 1. So that we have written here. Now we have to find what? Lambda minus lambda 2 and lambda minus lambda 3. Okay. So how will you get this now? This will be equal to this polynomial divided by this polynomial. So you have to do the division. How will you do the division? Lambda cube plus 6 lambda square plus 11 lambda plus 6 and this is lambda plus 1. Lambda square, lambda into lambda square will give you lambda cube. First term you have to see, right? And this is going to be lambda cube plus lambda square. So what you're going to get if you subtract 5 lambda square plus 11 lambda. Plus again what is the term you have to multiply with lambda so that you will get 5 lambda square. So this is 5 lambda. 5 lambda square plus 5 lambda will give you 6 lambda plus 6. So finally you will have to get 6. 6 lambda plus 6 will give you 0. Okay. So now this is the quotient, lambda square plus 5 lambda plus 6. Now this you can write as lambda plus 2 into lambda plus 3 by splitting the equation. So you have the other two roots are minus 2 and minus 3. So what are the eigenvalues here? The eigenvalues are minus 1, minus 2 and minus